Okay, so hello and welcome back. And now we're going to look at some more exponent laws, and now we want to talk about understanding negative exponents. Now, I'm going to break this down into two things. The one is where we're going to just look at how to deal with negative exponents, and then we're also going to relate it to the law that deals with negative exponents. Okay, so let's do that. Okay, remember, learn actively, take down the examples as I do them as well. Okay, so one definition, it says a to the power of negative 1 is equal to 1 over a. That's a law, right? So I'm just going to put that out there and tell you that's one of the exponent laws. Okay, and so how do I do this? Well, let's break it down and say, what if I have a squared, right, divided by a cubed? You're going to tell me that is exactly the same as writing it in the following way: a squared over a cubed. Okay, and if I have a squared divided by a cubed, I get the following. Using the quotient law, the law in which we subtract the exponents, we would say keep the base, and that's going to be 2 minus 3, and that gives me a to the power of negative 1. What I'm going to do now is take that exact same thing but do it in expanded notation. I would say, if I follow on from this here, that's a squared divided by a cubed. Now, as you know that a squared is a multiplied by a, and a cubed is a times a times a, right, 3 times. And if we want to cancel this, remember you can cancel factors when everything is being multiplied. So that cancels with one of that, and this one cancels with this one here. And then we're saying that thing divided by this thing. The answer is just going to be 1 in the numerator and that at the bottom. And that's how I get this thing over here. Okay. So let's look at a few more examples, and then I'm going to show you a quick way of dealing with negative exponents. What if I have a to the negative 2? That's going to be 1 over a squared. Okay. Similarly, this thing over here, a to the negative 2, is exactly the same as that thing over 1. Because remember, anything over 1 is itself. So what I can do now is I can say, well, okay, let me take this and say, take that to the bottom. Just move that down and the exponent becomes positive according to this law. If I look at this again, if I want to say, I want to break that down and say it's a cubed divided by a to the power of 5, that's going to give me a to the power of 3 minus 5. That's going to give me a to the negative 2. Okay, and if you want to do that in expanded notation, you're going to say it's a times a times a divided by a times a times a times a times a. And if we want to cancel, and we say how they cancel out, remember the only way you can cancel out things is if things are factorized. That means that there's only multiplication in the numerator and also the denominator. So one of those, one of those, one of those, one of those, and then one of those, one of those. And I'm left with 1 on top because it's 1 multiplied by each of these, and this divided by this is equal to 1. And then I'm left with just a squared at the bottom. And that's how I get that. Okay, so a quick way of dealing with negative exponents. Well, I'm going to let you in on a little secret. A to the negative 2 can be written as a in a bracket to the power of negative 2. Okay, let's just make that an a to the power of negative 2. If I write it like this, these two things are identical. So let's break it up as follows. Let's say you're looking at that thing. Well, I'm going to show you a quick trick. The trick is just make the exponent positive, right? Make the exponent positive, and then all you need to do is this thing here, a is exactly the same as a over 1, because anything divided by 1 is itself. So I'm going to say the trick is make the exponent positive and flip this. Give us the reciprocal. This is called a, right? This is a over 1. The reciprocal of this is 1 over a. So all you do is you take the reciprocal and change the exponent to a positive exponent. Example, a squared. And using the previous law we said if you get a fraction and that fraction is raised to a power, all you need to do is take the top to that power, 1 squared, and the bottom to that same power, which is a squared. Okay, 2 or 3 more quick examples. Remember, all you need to do is flip it. So what if I gave you something like 2 over 3 to the power of negative 4? Well, just flip it. Make it 3 over 2 and raise that to a positive exponent. And that's going to give me the following. It's going to say, well, that's 3 to the 4 over 2 to the 4. Yeah, I took... Similarly, if I... That's correct, right? That's done. If I were to take this thing over here and write it out, 2 to the negative 4 over 3 to the negative 4, all I need to do is take that down, and it becomes a positive 2 to the 4 by definition, and this is going to become 3 to the positive 4. Just take that to the top, take that to the bottom. Just move things up or down. Okay, so one of the things is if I had to ask you to write things in positive exponents, for example, x to the negative 4 divided by y to the negative 8, you're going to say that is going to be the same as saying y to the positive 8 divided by x to the positive 4. If we were to say, okay, let me go back. If we were to say, and we take another example, and we say x to the negative 6 divided by y to the positive 6, well, what can I do here? I want you to write this with positive exponents. Take that down. That's just going to be x to the positive 6, y to the positive 6, and you're left with this invisible 1 that you had over there. You can now put it in. Okay, so that's a quick crash course in some of the laws of exponents. What I want to do in the next video is just run through a few different examples in which we have to apply all the rules put together, and that will introduce us to something called a little bit more complex procedures when we start using more than one rule together. Okay. Final example, what about x over y to the power of negative 2? It's just going to be y. That's negative 2 over x to the power of positive 2, which is just really y to the 2 over x to the 2. Okay,